Hi everyone, today I'd like to talk about drawing vectors. So the first thing I'm going to do is go here to some graph paper and I'm just going to print screen down my X and Y axes. And the first vector I'm going to draw is a vector U. So I'm going to label it U equals angled bracket 3, 1. So what that means is I'm going to start at the origin and I'm going to go over 3 units in the X direction and 1 unit in the Y direction. So you can use the angled bracket notation for vectors, or sometimes you'll see this written in component form like 3i. I is the unit vector in the X direction, plus 1j, and j is the unit vector in the Y direction. So however way you go, we're going to start at the origin. So I'll start there, and I'm going to go over 3, up 1. So let's put that vector in. And I'm going to call that vector U. Vector negative 2u. So if I want to multiply, scalar multiplication of vectors is going to be negative 2 times angled bracket 3, 1. And that's going to give me a new vector, negative 6, negative 2. So that means I need to go over negative 6. So 2, 4, 6, and I need to go down 2 units. So let's draw that vector in here. And I'll label that negative 2u. So notice that those vectors are parallel. They have the same angle when I look at the angle made with the x-axis there, so they're at the same direction if you want to think about that. The magnitude is different, so the magnitude of negative 2u is twice the magnitude of vector u, and that negative scalar really took that angle and shot it back through the origin. So those are some nice observations to make there. All right, now I'm going to move on and do another vector, and this is going to be my vector v. So let's start off with vector v. And for vector v, I'm going to let this be over 1, up 2. So let's draw that on our set of axes here. So this is again 1 in the X direction, 2 in the Y. Here we go. Over 1, up 2 puts me right there. So I'll label that vector V. And now I'm going to look at a vector 3v. So 3v would be 3 times the vector 1i plus 2j. I'm just mixing the notation here so you can be comfortable with both the I and j notation as well as angled bracket notation. So again, scalar multiplication here, I'm going to have 3 in the I and 6 in the j. So over 3, up 2, 4, 6, going to put me right there. So notice again that the scalar of 3 made my vector 3 times as long. I'm in the same angle, same direction. I didn't shoot back through the origin or anything weird. This is going to be 3v. All right, now what we can do is we can make a parallelogram and then compute the cross product to find the area. So let's go through here and make a parallelogram. I'm going to try to copy the same vector 3v and put it over here. So notice that if I want to replicate 3V, I need to basically take a starting position, go over 3 units to the right, and up 6. So I'm going to start here, and I'm going to go over 3 units, 1, 2, 3, and up 6. 1, 2, 3, 4, 5, 6. So I need to end right there. So I've just taken vector 3V and drawn it within a different initial or starting position. So that's also 3V. It just is not in standard position. It's not starting at the origin. I just started it over here. And the same with this vector negative 2u, I could draw that type of vector with the opposite direction to complete my parallelogram. So let's just finish that off. I'll use a different color. Is to find the area.